Right, guys, today we're doing R cos alpha and sin alpha, the topic I hate to teach. Find it very hard pointing, saying stuff slower and loud. I have to use all the techniques we learn in teacher school. Yeah, I'll just normally say it slower and louder. So I think this might be the best I ever taught it. So I have to think a lot about this. Let me go back a page. So simply, when we've got something, say 4 cos alpha plus 4 sin alpha, we're going to look at the result when we put these two together. So let me ask you the question: if we combine a sine wave and a cosine wave, what do we get? A sine wave or a cosine wave. Sorry for the typo there. It might be bigger or smaller. Those of you who do physics will realise, or have ever done it, that the link is with constructive and destructive interference. So you might get two waves together, boom, it gets louder, or boom, it gets smaller. Yeah? Either way, the waves change. If you think about a sine wave and a cosine wave, essentially the same thing, just moved over a little bit. So what we notice when we combine the two waves is the magnitude, i.e. size of two waves, is R, and that the wave has been translated by alpha degrees horizontally, yeah, that way. And that's what I'll explain how we get R and alpha in a second. So to do this, we need these formulae again that are from the formula book, but we need to interpret it the other way around. So it might help you just to write it, when you're doing these questions, just write the formula the other way around. Don't copy it exactly as you see it from the formula book. Just switch the equal sign over, or the equivalent sign over. Because what we're going to be looking to do is match coefficients. So let's go straight into example here. So the question tells us we want sine x minus alpha. So I look at the formulae, and it's this one here that we want. So we copy that down. There's an R in front. That means we times everything by R. Yes, you can see there I've put an R in front of the whole equations. Now we match coefficients. So what I mean by that is that 7 is matched up with R cos alpha, and the 4 is matched up with R sin alpha. So that tells us that 7 is R cos alpha and 4 is R sin alpha. We ignore the minus signs. You don't need to worry about them. And R is simply the square root of those squared. So job done. So we've got square root of 7 squared plus 4 squared is root 65. That will always be the case. We always do that to find R, and we always do that to find alpha. So we can figure out, now we know R, it follows that we can figure out what alpha is. So if R sin alpha is 7 and R cos alpha equals 4, we get alpha, well, in radians, is 0.519 radians. So the final answer is 7 sin x minus 4 cos x is root 65 sin x minus 0.159. So when we're talking about the graph, the resultant wave of 7 sin x minus 4 cos x has been stretched in the y direction, root 65. So it has a magnitude of root 65, and it's been shifted right, which is, this is my right, so that was your, so it's shifted to right 0.519 radians. Yes, so it's translated parallel to the x-axis, and it's been stretched parallel to the y-axis. Now, in that yellow box in the corner, you can see I've shown you how to find R. That will always be the case if we label A and B as the coefficients in front of the sine and the cos. We could have done alpha was tan inverse of B over A. I prefer the way I did it, but if we did that, we'd have got the same answer. I think I had that somewhere. and we would have got the same answer. So I hope that makes sense. Now you need to practice. So that is the example in full. Copy that down. Obviously, take a moment to pause the video and copy it down. And then give those a go, please. Do as many as you can. And I'll go through the solutions next video. Adios.